Imagine yourself standing on the dusty red surface of Mars, gazing at a barren landscape beneath a pale pink-tinged sky. It looks lifeless and harsh, a land of thin air, biting cold, and fierce dust storms. Yet for dreamers, scientists, and engineers, Mars is more than a hostile desert. It's our next big frontier, where we might someday build thriving communities. But how could we possibly turn this frozen, radiation-battered world into a place where humans and whole ecosystems can flourish? That's the heart of terraforming Mars, reshaping a planet with barely any atmosphere into a world that could support life as we know it. But before we explore how, let's ask, why Mars in the first place? Saturn's moons, Jupiter's moons, even Venus have captured our imagination. But Mars remains our top candidate. It's relatively close, has a day length similar to ours, and most tantalizingly, it was once warmer and wetter. Long ago, rivers, lakes, and maybe even oceans coveted its surface. If life ever existed there, it did so under conditions that echo early Earth. Maybe if we find a way to warm the planet and boost its air pressure, we can reignite something of its ancient climate or build a new one from scratch. Terraforming means large-scale changes, thickening the atmosphere, boosting temperatures, and ensuring a stable water supply. The concept started in science fiction, where authors imagined enormous machines turning Mars green. Over time, as our probes roamed the Martian surface and companies built advanced rockets, terraforming crept closer to serious scientific discussion. But the reality is daunting. Mars' atmosphere is only about 1% as dense as Earth's. One common proposal is to use greenhouse gases to trap more heat, melting the planet's ice and releasing carbon dioxide. If that process took hold, warming would accelerate, and more trapped CO2 would release in a feedback loop. Other ideas range from crashing ice-rich asteroids into Mars to setting up giant orbital mirrors that concentrate sunlight onto its surface. Whatever the method, this project would take centuries, maybe millennia. In the meantime, human explorers would live in sealed habitats, reliant on technology to provide oxygen, water, and protection from radiation. We could use techniques like hydroponics or genetically engineered crops to grow food inside. Perhaps underground bases might be safest at first, with soil acting as a natural shield. Eventually, if the atmosphere thickens enough, people might step outside wearing only lightweight gear. That sounds far-fetched until you remember that walking on the moon once seemed impossible. However, creating a thicker atmosphere on Mars won't help much if the planet keeps losing it to solar wind. Mars lacks a global magnetic field, which on Earth deflects harmful particles from the sun. Over billions of years, this helped strip Mars of its once thicker air. Some scientists suggest placing a large magnetic shield at a point between Mars and the sun. Others imagine drilling into the core or deploying satellites that beam electromagnetic energy. Each concept faces enormous engineering hurdles, and we don't know if any of them would work indefinitely. Then there's the sheer scale of the timeline. Even the rosiest projections place full terraforming at hundreds of thousands of years. That's a huge challenge for funding, political resolve, and international cooperation. Governments, corporations, and generations of people would have to share one gigantic vision. Is humanity even capable of maintaining such focus for so long? Ethical questions add another layer. Mars seems sterile as far as we can tell, but we haven't explored every hidden nook. If microscopic life exists there, importing Earth-based organisms could threaten that alien biosphere. If Mars is truly lifeless, then it's a blank slate. But should we feel entitled to remake an entire planet? The debate touches on planetary protection, our responsibility to safeguard environments beyond Earth, and on moral questions about what it means to alter a world. There's also the reflection on our own track record. We've transformed Earth's climate and ecosystems, often with damaging results. Could terraforming Mars repeat those mistakes? Or might the challenge drive us to develop new, cleaner technologies? Some argue that striving to make Mars habitable could spark breakthroughs useful for addressing climate issues on Earth. It could unite people around a grand goal, encouraging more sustainable practices and cross-border collaboration. Or it could distract us from pressing problems at home. Meanwhile, organizations like NASA, SpaceX, and others are taking practical steps. NASA's Perseverance rover hunts for signs of past life, and tests an instrument called MOXIE, which produces small amounts of oxygen from Martian CO2. Though modest, it's a key proof of concept, using local resources to generate what we need. SpaceX is developing reusable rockets to make space travel more affordable, hoping to eventually transport cargo and people to Mars in large numbers. These early efforts, while nowhere near terraforming, lay the groundwork for a permanent human presence. The earliest human footprints might grace the red planet in the 1930s or 1940s. A stable base might come a few decades later. But as for turning Mars truly Earth-like, that remains a maybe, dependent on whether enough CO2 can be liberated to build a dense atmosphere. Some estimates say there isn't enough carbon dioxide locked in the polar caps or soil. Others believe artificial greenhouse gases might fill the gap. The debate is ongoing, and new data from our robotic explorers could tip the scales one way or another. Terraforming Mars might well become a unifying mission for humanity. Throughout history, large-scale endeavors, from building pyramids to landing on the moon, have inspired societies to reach new heights. Terraforming a planet is that idea on steroids. It could inspire generations of innovators and students dreaming of careers in planetary science or space agriculture. But we have to be realistic. Even calling it terraforming might oversell our abilities. Earth's climate is complex, and we're just beginning to grasp how to manage or mismanage our own planet's environment. Mars, simpler in some ways, still poses unprecedented challenges. Low gravity, radiation, no magnetic shield, and no plate tectonics. Partial terraforming is one possibility, focusing on specific regions or sealed biospheres, leaving much of Mars in its natural state. Perhaps future human generations will maintain a hybrid world. A few pockets of lush, engineered landscapes surrounded by vast deserts and ice fields. Creating seas and craters, introducing hardy organisms, and carefully managing greenhouse gases might result in a patchwork of ecosystems over centuries. Even then, any new environment could look very different from Earth, with unfamiliar skies and peculiar plant life adapted to red soil and weaker gravity. For now, continued robotic exploration is vital. Each rover or lander that studies Martian rocks, ice, or atmosphere adds data to our models. We need to know precisely how much water is below the surface, or how the dust might affect machinery, or what happens when small-scale organisms are introduced to Martian soil simulants. Every piece of knowledge helps us understand whether terraforming is feasible or if it will remain a vision forever trapped in science fiction. But the true impact of terraforming Mars, even hypothetically, goes beyond technology. It challenges how we see ourselves. Are we bold explorers, shaped by curiosity and ambition? Or are we cosmic meddlers risking unknown consequences? If we succeed in breathing life into a dead planet, it would be one of humanity's greatest achievements. If we fail, we'd learn a sobering lesson about our limits. Either outcome will likely redefine our identity as a spacefaring species. Perhaps the greatest value in the terraforming conversation is that it reminds us of our power and our responsibility. We are already terraforming Earth, for better or worse. Our factories, cars, and deforestation are altering our home's climate. If our goal is to remake Mars responsibly, maybe we can start by learning to live more sustainably here. And if that journey someday leads to standing under a blue-tinged Martian sky, breathing air we helped create, it could mark a turning point in the story of humanity, one that echoes back to Earth, guiding us to be better stewards of both worlds. Thank you for joining this exploration of terraforming Mars. The challenges are immense, the timeline is overwhelming, and ethical questions abound. Yet the dream of turning the red planet into a cradle for new life continues to spark our imagination. In that spark lies the promise that maybe, just maybe, we can learn to care for our own planet, even as we reach toward the stars.